Alright, first thing I need you to know about this is there's going to be a part 1 and a part 2. So about 5 minutes into this I'm going to stop and then I'll start part 2 after that. So as I had mentioned in class, we've been solving equations that have one variable on one side of the equation. Now we're going to start solving equations where the variable is on both sides of the equation. And there are some steps here. Simplify both sides of the equation if necessary. Sometimes you won't have to simplify either side. Sometimes you might have to simplify one. Sometimes you might have to simplify both. Second step that I like to do is bring the variable terms together on one side. That's what I call bringing together your besties. So your best friends, you want to bring your best friends together when they're on opposite sides. And then 3, we will solve the variable like we normally have been doing. So for instance, let's take a look at this first example. We have 7k equals 4k plus 15. Now this is where it's going to be a little more crucial to follow the correct steps because now it's a lot harder to guess and check. And this is a very simple one to start off with. It gets a little more complex as we go here. So here's what I like to do. I don't have to simplify either side of the equation. 7k is fine by itself. 4k plus 15, I can't simplify that at all. So I have a decision to make. Either I'm going to bring 7k over to the right, or I'm going to try to bring 4k over to the left. Either way, I would have to subtract either of those terms to bring it to the other side. So I can subtract variable terms just like I can subtract 15, for instance. But I have no reason to subtract 15 on both sides. I want to bring my besties together first. So 7k and 4k, they're besties. BFFs, whatever you want to call them. So I'm going to subtract 4k on both sides. 4k minus 4k cancels. I'm left with 15. And now I do 7k minus 4k. Well, if I have 7 total k's minus 3 total k's, or 4 total k's, I get 3k is left over. And now we have a very simple problem to solve. 3 divided by 3 cancels. K equals 5. And that is our solution. Now some people are going to wonder, well, what if I would have made the decision to bring 7k over to the right instead? Real quick, I'm going to show you what that looks like. It's actually a little harder that way. And you'll get used to making the correct, well, it's not wrong, but you'll get used to making the easier decision and making it easier. 7k minus 7k is 0. 4k minus 7k is now negative 3k plus 15. And basically what you're going to do at this point is you've created a little bit harder of a problem. You want to now solve for k, so you would subtract 15 on both sides. Oops, sorry, that doesn't cancel. You get negative 15 equals negative 3k. And you're still going to come out, once you divide by negative 3, that k equals negative 15 divided by negative 3. K still equals 5. Alright, so like I said, it still works out, and that's the only reason I'm showing you that. But you'll get used to making that choice to bring it over to make the decision easier and the problem easier. Alright, this example kicks it up a little bit. 2k minus 5 is already simplified. But I do notice I've got 2 variables on either side. Here I have to do a little distributive property. So 3 times 1 and 3 times negative 2 minus 6k. Alright, so we have to decide, am I going to try to bring 6k over to the left? Or am I going to try to bring 2k over to the right? Doesn't matter. However, I like to try to keep everything positive. So I'm going to add 6k to both sides. I want to bring those besties together. Negative 6k plus 6k cancels. Left with 3 over there and then minus 5 on the left. Now 2k plus 6k is 8k. Remember, I can combine those just like we did before. Now I'm going to solve for k. I brought my k's together, my besties together. I'm going to add 5 to both sides. Negative 5 plus 5 cancels. I'm left with 8k equals 8. And k then has to equal 1. That's our identity property. 8 times 1 is going to be 8. Alright, so like I said, this is part 1. Part 2, I got 2 examples for you. Should go by pretty quick. And we'll